Hello, ASUG colleagues. This is Chris from ASUG Alabama. I wanted to follow up on our meeting by giving you a quick tour of the SAP Analytics Cloud interface. I know that during our session I sort of had to rush through the demo of the SAC platform, and I just wanted to take a little more time and step through it and show you some of the things that we talked about. So I'm going to go straight into the tenant. And I'm going to log in here with my credentials. All right, and based on the demo that we had during our session, you're familiar with the screen here. So remember in the session, I presented 3 items that we needed to start building stories. First was a connection. The second was a model. The third is a story. So remember, we had gone to the sidebar here, went to our connections, and we explored the connections that are available. We clicked the plus sign, the connections that are available within the SAC platform. So we have live data and acquired data, and you can see within the live data section we have SAP BW, DataSphere, HANA. We also have a few here that I would need to upgrade because right now I'm working on a trial in order to access, so BPC, S4HANA, and SAP Universes or Webby reports, Web Intelligence reports within the Business Objects platform. So all those are available live, and there is a live data connector you would have to install depending on the connection you're making. And then these are all the acquired data connections. So we have a full listing here, and then we can scroll down. Anything that's grayed out, you would need to upgrade to the full version to access, and that includes the SAP Universes if you're using any Universes currently. Dropbox, there's OneDrive for Business, and things like that. And then, importantly, I wanted to point this out. We also have SQL databases. SQL databases would allow us to connect to, say, Oracle databases or Microsoft SQL Server, MySQL. I think there's even a Snowflake driver in there. There's a long listing of drivers once you install the development kit, the deployment kit, that allows you to connect to those data sources. So that allows you to connect to a lot more. The one thing I also wanted to point out here is success factors. I know we talked about success factors in our session. There was also a connection in here to Salesforce at one point. Let's see. Yeah, it looks like they dropped the Salesforce connector out. That's interesting. So we likely have to use then, rather than connecting to Salesforce directly, using the API connector to get into Salesforce. So, and that's down here at the bottom. That pretty much opens up everything. So if you create an API or subscribe to an API, remember API is application programmer or application programming interface that allows you to use a URL to access an application's data. So you might have that. So I'm going to hit cancel here. And what we did was we used a spreadsheet and imported that spreadsheet into SAC. So I'm going to do that here. And remember, I'm not going to create a connection to that spreadsheet. The thing that we mentioned in our session is that I could create a file server share. And those file servers, you can set those up as a connection and then drop a file into that network share, that file share. And then every time the spreadsheet updates, you can refresh your model with the latest data. But what I'm going to do here is go into Modeler. And we got a pop-up here just that gives me new information. I'm just going to click Close here. And there's our ASUG insurance data. But I'll walk through that process again and show you how we built this. So I'll go Create Model. And we can either start with data or start building an empty model if we wanted to build our own data. This has to do with master data management and being able to very tightly control what's in a model in SAC. But since we're starting with a spreadsheet, I'll just pick Start with Data, pick Next. And here we are, we have local file or file server. So I'll pick that. I'll go pick a source file. If we did have a file server, you would have seen a radio button that would allow me to select the file server rather than a local file. So I'm going to go into my datasets directory. I'm going to grab that insurance dataset that we talked about. I'll pick Open. And it's going to open that up. Remember, use first row as column headers, and I'll pick Import. And so this is importing the data into the model like what we saw in our ASUG session. So it's opened that spreadsheet, it's looking at all the columns. We specified the first row as a column header. So that will be our column names. And then this will bring up all of our metadata. So all of our column technical names, descriptions, data types, and so forth. So we had gone through these and we had measures and dimensions. Remember, measures are calculable numbers. So fields like we have injury claim, property claim, and that's where we can sum those up. It's identified the year for the automobiles as a measure. That's a bit debatable. You can change that from a measure to a dimension if you'd like, just by going in and changing some of the properties over here. So we can change that around. But what I'm going to do is, then we go down here to the dimensions. Since I talked about measures, let's get into dimensions. So with the dimensions here, you see that it's identified two of my dates as date types. So it's going to specify those and allow me to drill down into my dates. And the policy buying date and the incident date are two dates that it's found. And then there's all of my insured's demographic information. There is incident information. Remember, this data set is an insurance data set that shows me all the incidents of car accidents throughout a multi-state region. And then, most importantly, down here at the bottom, whether or not fraud was reported. So what I'm going to do here is in my dimensions, I'm going to change a couple of these things. So I'm going to pick fraud reported. And remember, we changed the description to make it something more friendly. It doesn't have to be fraud reported. It can be anything that your end users would recognize as a correct name for the field. And I'll pick, say, incident state. Just do a couple of these. Okay. And we'll leave the rest. Then I'll go into measures. I'll change total claim amount to that. Injury claim, we'll do property claim, and the last one, vehicle claim. Because injury, property, and vehicle claim, if you summarize those three fields, you'll get the total claim amount, so you can validate your data. All right, so then if you look up along the top here, we have some options. Of course, we have our save. There's model preferences. You can share the model out with your colleagues if you'd like for them to see it, undo, redo. There's the ability to add custom measures and dimensions. So if you wanted to associate another dimension with this data, you can put in your dimension, you can type in all the master data, and then associate those records with that field, or with your data. You can delete fields if you'd like. Like I typically go down here and delete this column 39 data because it's just blank data anyway, but it allows you to clean it up. You can specify variables like prompts in your data so that if you wanted to say automatically prompt the user for a state, you could do that. This has to do with data locking and modifying data after you've built it. And then you can look at the overall data set here. And then of course there's the details here. So you can open the overall model properties. And you can see that this was enabled for planning. If you don't want to enable this for planning, like headcount planning or financial planning, you just turn that rocker off. And then these are your individual measure properties. So you also have the ability of looking at calculations, and we did not go over this in the session, but you can create calculations on your data. Like I mentioned, the injury, property, and vehicle claim, if you summarize those, that would give you your total claim amount. So I could create a calculation that summarizes those three fields. And you'll see down here at the bottom right, I can go into this formula editor. I can put in my field names if I'd like, just by picking the open bracket. Go pick injury claim plus vehicle claim plus property claim, and hit OK here. And now that's and so I call this total claim amount, or TCA, calculated. And we can use that in our calculation. I need to put in an underscore there, and then I can call this TCA calculated as the friendly name in the description. So that's how you can create calculations. So whatever sort of calculations you need to do on your data, this is done here. I wouldn't get too complex with that because you want to make sure that all your calculations are done as close to where the data lives as possible. That way your visualization layer will perform as fast as possible without having to do calculations prior to drawing anything on your story. So with that done, I'm going to go over here and pick save. And it's asking me what I want to save it as. And I'll say ASUG follow-up data and pick save. All right. So now this has acquired the data from that spreadsheet on my desktop into the SAC platform. And remember, SAC runs on top of an instance of HANA. So we're loading that data into HANA. And that's what it's doing right now, is it's just saving all the data. Model saved. I didn't turn off planning, so it added a version dimension. And we're all set here. And this actually lets us go and look at the calculation. So we could do a quick view of the data. If you wanted to set up rows and columns, you can see that all the measures in my data set are already laid out here, and I could go in and add more. So if I wanted to look at, say, we take fraud reported. It's going to take the individual values of fraud reported, no and yes. Has fraud been reported, no or yes. And then dividing up, let me close my properties here, dividing that up by injury, property, vehicle claim, and then there's our TCA calculated. So I could go in here and add in, those are the ones that are used, these are the ones that are not used. So I could put in my original total claim amount. And now before I even start visualizing the data, you can see that I can look into the data and do some validation. So I would expect total claim amount from the original data source would match what I've calculated here. And if you look at it, it looks like it's matching. So we're all good there. And we don't need to save anything, just close it. And now that we've built our model, we can go in and build our story. So we will build a story. And in the session, I showed you how we could use a canvas, and then we talked about the differences between responsive, canvas, and then also the smart discovery. So I'm going to go build a canvas. And in the session, we use this optimized design experience, which optimized design experience is the way forward with the SAC platform. But all the features that we have in SAC are not necessarily in the optimized design experience. You may see ODE optimized design experience. So what I'll do is I'll pick classic design experience and hit create. And there are some differences between the optimized and the classic design experience, because now rather than just getting the canvas, it's giving me a different screen here. So I'll pick add data, and it's asking me, do I want to upload data? Do I want to create a new model, or do I want to pull in an existing model? And I'll just pick an existing model, and we'll go pick our ASUG follow-up data. And so now this is interesting. With the classic design experience, we have this data explorer. And I really like this, but unfortunately this is being deprecated in favor of this data analyzer feature that you see on the left side. I like this feature. This was similar to the old Business Objects Explorer, because you could take, say, in your listing of measures, these are all the measures that we have in our model. I could pick total claim amount. And it would start giving me a visualization that's sort of a best guess visualization, or like it says here, auto-suggested. This is a numeric point. I could use this to start building my story. All I have to do is go over here, pick the copy button, copy to page 1, and see how it gives me a numeric point. I can resize that. And now I'm starting to build my story, looking at the data first, rather than coming at it from the different perspective, which is looking at the starting with a blank canvas and adding a chart. So then I've got this story in rocker, so I can rock back over to the data view, and we just saw this. So now I can pick show dimensions. I can pick all of my dimensions, or I could just look at incident states, fraud reported. We'll look at a couple of these other things. Let's see, auto make, auto model. All right, so now you see as I've picked those, it's added the dimensions in here and given me the unique values. If I wanted to look at total claim amount by incident state, I could just pick incident state, and now it's giving me a best guess chart here. This is similar to what we built yesterday, in the optimized design experience. In this data view, I can go up to the three dots. I could pick sort, and remember we did this yesterday, sort highest to lowest. And I could put in a reference line, dynamic reference line, and we did the average on the total claim amount. Looks like it's not letting me pick that total claim amount for some reason. Maybe a little bug in the system or in my browser. So I'll just hit cancel, but we remember seeing the average line as it populates there. So I can put this into my page 1, and now I'm continuing to build my story. I want to do a couple of other things here. I'll go back to data. I'm going to add a dimension, and I'll pick incident date. And there's my date hierarchy. Remember, it identified incident date as a date. I'm going to uncheck incident state, check incident date. And now it's giving me an auto-suggested time series. We saw this yesterday in the session when I was able to build the time series chart showing the total claim amount by incident date. So I'm going to copy that into my story. Here we are. Okay, so now that we've got the time series chart on here, I'll drag this out. And we'll go back and we'll just create this as a table. And I'll do something simple here. So I'll just drop total claim amount as a table, copy that to page 1. What I usually do in my demos here is I'll put in a map on the incident state data. But I didn't create a geographic type for that. So I'll just create a table here, and you can create a map. I'll typically show like total claim amount by incident state. So I'm going to go here, show hide. I'll take off the column row headers, and that'll free up some of that space there. I'll do show hide. I'll take off the table title and subtitle just to free up some space. There we are. And then we can open this out a bit more. All right. So there's our dashboard, and I had mentioned that with each of these components we have this more actions up at the top here, and that's where you can add things like your reference lines, and we'll see if actually let me do that up here. See if I can add in that dynamic threshold or that dynamic average on the total claim amount. Yeah, it's going to let me do it here. So there's my average, similar to what we saw in the session. So we have that. I'll pick OK. And now down here on the time series chart in the classic design experience, we can add our forecasting. So in the more actions on the time series chart, I'll pick add. And there's a forecast here, and I'll just pick automatic forecast. And so this is what we were talking about, and we saw this in the automatic discovery, where it'll look at the periods in the past and try to do a prediction of the data into the future. So it'll give me a line that'll show me what the values are for total claim amount for certain periods into the future. It'll give me the upper and lower confidence bounds. You can see that in the pop-up there. And we can see the overall, and it looks like it gave me a linear regression, because if you look at the way we can do these forecasts, we can do linear regression, triple exponential smoothing, either one of these two. We can also add other inputs if we know that we have other drivers that have an influence on this data. So we can pick those independently or just let it pick out what the best one is. So we see we have total claim amounts for the future that are declining according to the linear regression. And I'll draw your attention to the subtitle here. We have this forecast. And if it's green, that means it has a higher confidence that the forecast is accurate because we have a good variance of the data on the chart. So if you pick the forecast, it says we have 12 periods into the future. We have a forecast quality of 4 out of 5. You can pick the arrow here and it says it has a high forecast quality or a high confidence that the numbers are good. And then you can pick this and find out exactly what it did behind the scenes in terms of a description. It doesn't actually show you what it's done with your data, but it'll give you a description on how it came up with that number. So that's how we can use machine learning, in this case a linear regression algorithm, to predict our data into the future. So Other of these items, like I'd mentioned, doing smart insights, this is another machine learning feature. You can go to the more actions on any of these charts and you'll have this add smart insights. And this is another feature of the classic design experience. And it says loading insights. And it says New York has the highest total claim amount. Let me blow this up. With all of these features, all these chart items, we have this full screen option. So if you really want to focus on this full screen option, you can say New York has the highest total claim amount, which we see that showing 96% deviation from the average. Well, we see, all right, there's our average, 7.5 million, and this has almost 100% deviation from the average. The total so far in January 15 is 69,000. The total for December of 2014 was 72,000. So we're seeing a month-over-month difference, which is an increase of 28%, and it gives us the actual increase value compared to November of 2014. So we're seeing it's giving us some insights that it may find interesting. Even more interesting is this view more option. This will slide open a bar on the right side and give us information, deeper information about what we're seeing. So this is specifically looking at the elements, the data elements here, November, December of 14, and January of 15, and what the changes look like across those different months. And then also it shows us overall what the data looks like from month to month, quarter to quarter, and then over the 2 years. And then there are some contributors here. It says RAM is the top auto model contributor. So why are the RAM, the make RAM, a Dodge product, why is it contributing 38% of the total claim amount that we're seeing here? Are they more expensive to fix? Is this something we need to increase our insurance premiums on? So we may need to look at that, followed by the Jeep Wrangler, the Neon, and so forth. So that may be something interesting to look at. That's a contributor to the overall total claim amount. And then we have multiple vehicle collision is the top incident type, 100% above average. So multiple vehicle collisions are above average, as well as single vehicle collisions. Vehicle theft and parked car incidences are not nearly as high. So you can continue looking at these contributors. Machine op inspect is the top insured occupation. So now we're looking at demographic information. We're seeing machine operators, operator inspectors are the top contributor here to the total claim amount. What are they doing that's causing a higher total claim amount? Top incident location, incident severity. So it gives you some insights into what's driving that total claim amount. So, and then with any of these, like if you wanted to make the Dodge or the Ram total claim amount by model part of your story, so you find this interesting, you have a copy button here. I can now copy that into my story. And it's going to drop that in. I'm going to close the side window. And now there is that visualization that SAC just created on its own using machine learning. So now this is a form of augmented analytics where we didn't create it, we didn't ask for it, but the environment saw in the data that RAM is the top contributor. So in this, let me resize this a little bit more because with these insights, this is sort of cramped up at the top here. I'm going to drop that. I'm going to pull this down. What we could do is with these is set up some linked analysis. So I'll go into linked analysis here on the chart. And if I pick a value on this chart, I want it to filter out the values on the other charts. So I'm going to say pick all widgets on this page and then filter on the data point selection. And then if I pick OK here, I can go in and say pick RAM. And now you see everything else very quickly updates. So now I'm seeing the total claim amount specifically for the RAM. With the breakdown by state, we can still see that New York, followed by South Carolina and West Virginia, are the top three that are above average. And then we have a total claim amount by year, and then we can see the forecast. And then, I'm sorry, we can see the time series chart with the recalculated forecast. So it did that on demand. But if you look at this, the forecast is not as accurate. We now have a 1 out of 5. So you may need to add more more dimensions into that data that have a better feeling about that data, more of a contribution to that data. You can also look at the way that the data varies here. The less variance there is in the data, the lower the confidence is in the way that it can make a prediction. So we see pretty much a straight line here, which goes along with the linear regression line. And so it doesn't have quite as good of a feel that the data is correct, or the forecasts are correct. So that's the linked analysis. We didn't get to go over that in the session, but I mentioned it. That way you can focus specifically on something that has a higher contribution to what you're looking at, in this case, total claim amount. All right, I'm going to save this. And let's see. I don't have, where's my save button? Oh, there it is. It's in the overflow here because of the size of my browser. So I'll just call this ASUG follow-up. And remember, anything that you do in your trial version of SAC, you will not be able to translate into a paid version. So everything you do here truly is a trial. It's prototype, so don't build anything that you'll be using in a production environment, because once your trial ends in 20 days, you'll lose it. All right, so I'm going to close this. And now imagine I'm an end user. I want to come in here and view the story. I can go into my files and look for it, or I could just click on this. You can also share your files as a link. So I could take this hyperlink here and send it to somebody. They would have to log in, so they would have to have a license. But then they could work with the interface straight away like this. Oh, another thing I haven't talked about here. You see I've got two vehicles selected here. It's automatically giving me the difference between the two that I've selected here in terms of magnitude and percentage. So that's just a matter of picking one and then picking the other. And I can just drag it back and forth just to dynamically see the difference. Just a very quick way to get more insights and like differences between the two. If I go the other direction, you'll see the numbers turn positive. So let me get that window out of the way there. And you see the numbers start going positive there because I go from a lower number to a higher number. So that's interesting. All right, last thing I want to show you is what we did in the Smart Discovery feature. So remember, this is our Smart Discovery. This is Augmented Analytics, creates a classic design experience. Click Create. And I'll go pick my follow-up data model. And I'll tell it I want to know more about a total claim amount. I want to pull in a few items. Okay, so now that I've got Smart Discovery up, I can go to Target. I'll pick total claim amount. The entities, these are some of the entities that we picked during our session. I'll pick auto make, auto model, incident date, or incident city. The dates would, this says not supported, but we did see some time series charts in there. Incident location, actually I'll just do incident state and type, and we can pick up the 10 of these dimensions. Insured education, hobbies, occupation, relationship, sex, and fraud reported. Oops, I want to get fraud reported in there, so let me remove something else. I don't really care about the hobbies. I do care about incident state, but I want to look at fraud reported and see if that has any impact. So down here at the bottom, you see we have preview, run, and cancel. I'm going to close this. Oh, of course I just deleted everything. So auto make, auto model, fraud reported, incident state, type, some insured information, and I think that's all we've got, right? Oh, we've got one more. Incident, we'll say collision type. So down here at the bottom, I'll go ahead and close that. I'm not going to add any filters. Remember, we can add filters if your data set is massive and you only want to look at a certain years of data. We always say that COVID blew away any of our predictive models because the way that business was running prior to 2019, 2020, and then it took a huge dive depending on the industry, and then came back up as we came out of COVID. So the whole COVID thing blew away any of our predictive models. You can filter out the COVID years if you'd like, depending on the use case that you've got. I'll pick run, and I'll just let this process. And then remember, this comes up, this is looking at the data behind the scenes. I've not really told it anything other than we have this data, this is what it's named, these are text types, or these are dimensions, these are measures, and just building the model. So now the machine learning capabilities of the platform is looking at that data and is trying to find some interesting aspects to it. And what it'll build is hopefully a 4-tab or 4-page dashboard that describes total claim amount based on the dimensions that we picked. And if the dimensions that we picked has a high influence on the total claim amount outcome, then we'll get a lot of good data here. Otherwise, we'd have to run it again and pick out other dimensions that may have a better influence on that total claim amount. So this normally doesn't take too long to run, so we'll just let it run here for a moment. All right, there we go. It's all done. It gave us the 4 tabs. So remember, it first gives us some statistics, total claim amount, grand total, minimum value of 100, maximum value of 114,920. That's our maximum fraud report, our maximum total claim amount. We have buckets. We can see that the majority of our total claim amounts are in the $57,000 to $64,000 range. We do have a high number down here in the very small claims amount, followed by $7,000 to $14,000, but follows a typical bell curve with a lower entail there. We can see a total claim amount here over time, and this has a high forecast confidence. So again, you could click that and see 4 out of 5, similar to what we saw before. And then total claim by our different dimensions here. These are a lot of dimensions to divide up. I don't really like this chart because it's too much data. We'd have to filter some of this data out. So we can see that in this case, the highest claim amount, which is our maximum value of 114,920, was an Audi A3 with no fraud reported in the state of South Carolina in a multi-vehicle collision. It was a high school, they have high school education, they're executive managerial. So gender female, it was a front-end collision, it looks like. So a front-end collision, multiple vehicle. So that combination of data gave us our highest maximum value, followed by the next one down here, and you can see what the combination is there. So then we go into key influencers. So you can see based on the dimensions that we've got, all the dimensions that we picked have a weak relationship with the total claim amount. Injury claim here is the one value that has a moderate influence on the total claim amount. So we have higher injury claims on our total claim amount. So you see here that we have how to interpret the data here. It says we've excluded vehicle claim from the predictive model because it's highly correlated with the total claim amount. Basically, as the total claim amount increases, vehicle claim increases. So it took it out because it really wasn't a good indicator of our total claim amount. So we have a few other charts down here at the bottom. We can play around with these and look at different, the binning, the way that it did this, and look at the influencers. So you can play around with those and do some analysis. There's a lot here. So make sure you read through the charts there. The unexpected values is what I found interesting. Out of the 1,000 records that we have in this data set, we have about 5 records or 5 injury reports or 5 vehicle insurance claims that were outside of what was expected. So we have a total claim amount actual of 95,000. It ran its predictive algorithm to try to figure out, is 95,000 correct based on the values of the other claims? And it said that the value that was expected for this specific incident was 66,000. For some reason, it's $28,000 over what the prediction said, which is a 42% difference. And then we can look at some information about those. Is fraud reported? No. Well, if we have a lower number, if we have a higher number of 95,000, yet we're expecting 67,000, is there fraudulent activity here? And should we investigate that further? We have 3 records like that we could potentially investigate to say, no, we're not going to pay this claim because it's fraudulent. And then we have 2 here that are fraudulent. Those can just be kicked out because we see that the actual value is 55, interestingly enough. the total claim amount, the expected value was higher than the actual amount, which doesn't make sense, because if the expected amount was, if there was fraud reported, we would expect the actual total claim amount to be higher than the expected. So there might be just differences in the data. So we can play around with those now. We've got a couple of items here that show that the expected value is higher, this is above the line on the actual. We have two items here that their expected total claim amount is higher than the actual. So we have our line here that shows what the norm is, but then we have a expected value here that's higher than what the actual is. So we might want to investigate those two. It's likely those two are going to be the two fraudulent items here, because the expected value is higher. But you'll see over here that whenever I pick these two, that it's highlighting the specific values. It looks like that linked analysis is turned on. So as soon as we pick these items, it just shows us the two here, the actual versus expected. And we can do our calculation between the two if we like to see what the difference is. Last item here is the simulation. We discussed this, the way that you can go in and manipulate, say, injury claim, property claim, change those values around. The collision type here, we could specifically look at front-end collisions. We could play around with occupations and see if we, if we decreased our property claim, so we're able to decrease that to 7,800. And we have the insured's level, so we only want to focus on college-educated people. Hit simulate. You see that has a that would actually increase our total claim amount by 9%. So you can play around with these numbers and see what the relationships are. So if you wanted to fine-tune or play around with these and figure out how you want to change your business practices to focus on decreasing that total claim amount, this is one way you could do it. And if you find that a lot of these dimensions of these objects don't have a tighter correlation with the outcome of your TCA, then you could rerun another smart discovery and find other dimensions that may have a tighter correlation. That way you'd have more to play with here. So that's all I've got for today. I just wanted to spend more time on this and take some time to do this. I can save this, and I'll pick save, and we'll call this ASUG Smart Discovery. And this just becomes another dashboard. But remember, this is augmented analytics. This is how we can just take data, have machine learning run its algorithms, and have it build a series of stories for us that we can then use and analyze that data without us having to build anything. So we could start with this if we wanted just to analyze some data sets, and then go from there, and then we could build our own. You could actually take parts of this, integrate this in with your own dashboard, and then tell your own stories. So I hope this has been helpful. Feel free to reach out if you have any questions, and thanks for your time.